Hello, my name is Marcus Schulz and I'm a project manager at NovelSense. Our team would like to present to you today METACUS.AI, the meta-orchestrated European sensor grid. METACUS.AI is a Nephele Call 2 Type 1 project. It was executed from January to July 2025. In the project, we are transforming the DEUS air pollution and emission monitoring system to a more flexible, scalable system. DEUS is Europe's largest network for environmental and traffic monitoring. It is fully Europe-based and owned. It offers real-time environment data visualization and analysis for public and private sectors. The DEUS hardware consists of a modular framework offering sensors such as particulate matter, carbon dioxide, weather, methane, and traffic. The goal of the project is the transformation of DEUS using the Nephele VO stack. Hence, in stage 1, we newly designed the METACUS.AI architecture. In stage 2, this architecture was successfully implemented. The system was then deployed in our real-world testbeds. And finally, we generated performance indicators to evaluate the solution. Let's take a brief look at the implemented architecture. At the top, we find the business logic layer on which we are running our monitoring dashboard. This is a global singleton. In the cloud layer, which is deployed per installation, we are running the DEUS customer dashboard and the sensor station CVOs. In the edge layer, which is also deployed per installation, we run the sensor-specific VOs and the middleware. And finally, in the device layer, we have the physical DEUS sensors. To see this architecture in action, we are going to show a demo on one of our testbeds. The basis of this demo will be testbed 1. Here we have a single installation consisting of 8 sensor stations connected to a single cluster. Let's now see the demo.
So currently we are on Nephele UI. Here we can see different CVOs, views that we have on the HDAR on our main server. Same goes for these application graphs for different sensor stations. We also have on this same HDAR. We are going to deploy most of these application graph for the sensor stations. And we can confirm this on the operations table that all of the sensor stations have been deployed to the default cluster, our main cluster running on our main server. Here we can see in the kubectl most of the CVOs and VOs that have been deployed from the Nephele UI, and here we can see the resources used by the pods, the CVOs, the VOs, and here goes the customer dashboard. Here we can see the data that have been sent by the sensor stations to our VOs from different sensor stations, as you can see. And same goes for the weather station. Currently we have one sensor station online. Here is the traffic, and we are seeing currently the service dashboard where we can see different sensor stations that are off online, and we can capture the image from one of the sensor station. So this demo is concluded.
We hope you enjoyed the demo. As mentioned, we also assessed 6 performance indicators defined at the beginning of the project. Thereby, TKPIs 1 and 2 are completed by the included demo and by specific submissions to the reviewers. TKPI 3 to 6 will be discussed on the following slides. The TKPIs 3, 4, and 5 all measure specific latencies along the application graph. Part of these TKPIs is the comparison to the stage 2 results, and it was defined that the current measurements should not exceed threefold of the stage 2 measurements. As you can see from the green numbers in the tables, we are happy to report that this is the case for all the TKPIs listed here. Finally, TKPI 6 assesses the time between running our graphs on a single cluster versus running it on 2 clusters. As we can observe from the tables, the deployment time is reduced when running on 2 clusters. Based on the observed behavior, no latency issues for scaling to larger configurations are expected, therefore validating the installation per cluster approach for METACUS.AI. This brings us to the final slides of this presentation. The following major outcomes were achieved. The transformation of DEUS from a vertical monolith to a modular but unified edge-to-cloud architecture featuring a high degree of openness, interoperability, and extensibility with data separation and privacy as foundational properties. And many additional USPs such as scalability, governance, and reduced deployment effort. Hence, our next step will be to conduct targeted reviews with the DEUS partners, showcasing the solution and suggesting its adoption. In conclusion to this project, we would like to highlight the key benefits achieved by employing the Nephele framework, including a comprehensive feature set built on paradigms, standards, and technologies, the reduction of challenges to adopt next-generation orchestration, and a clear and efficient path to modernize edge-to-cloud systems. Following this path, especially these features provided significant value for METACUS.AI. The VO stack with its VO and CVO concepts, the ingrained enhanced data governance, and the deployment management through the SMO. In our view, these benefits make Nephele a standout choice for efficient, secure, and interoperable orchestration of distributed cloud edge IoT applications throughout European industries. Thank you for your attention and have a great day.